Welcome to Two Brave Unicorns. Today, we're blasting off into the future with someone who has literally helped build the United States Space Force from the ground up. Our guest is Dr. Joel Mozer, PhD, retired chief scientist, first ever worth noting for the United States Space Force, and more than 30 years of experience designing, testing, and deploying the kinds of satellites, sensors, and space systems most of us only see in the movies. Actually, we probably don't see them in the movies because they are classified. Fair warning to our listeners, Joel is extremely smart and speaks fluent space and science. And my co-host, Keri, is right there with him. They can go very deep, very fast. I'll be here making sure we translate all that into everyday language so no one gets left behind. No PhD required to enjoy this conversation. We're so excited to have you talk with us about the future of space technology and innovation.
Well, thank you very much. I'm thrilled to be here. What could be better than talking to two unicorns?
I will say really quickly, when I shared the name with Joel, he said, well, but unicorns are one just by the nature of the word. I have known you for a while now and have gotten to know your story and just how impressive you are. But for people who are listening, can you kind of tell your journey of being from being a kid to what you wanted to be when you grew up to how you became what you were when you grew up?
I guess you could say I've always been somewhat of a geek. I've always been sort of curious about things. And when as soon as I, as a young kid, learned about science, just fell in love with that. It's like a big game of mystery. You have a question, you don't know how something works. You go find out how it works, and that's what you do as a professional scientist. So what could be better, right? So I'm the kind of kid that would take apart things like crazy when I was little. Sometimes I'd get around to putting them back together, but you can ask my mom. I tore apart all kinds of things just to see how they worked.
Yeah.
And all through school, that's what I enjoyed doing, and I like tangible things. So I discovered the world of physics. So I love physics, but I'm a little bit weird. I wasn't particularly enthralled with things like atomic physics or quantum physics, because those are things that you can't really touch them or feel them. They're not very tangible. So I like the atmosphere. And maybe I was a dreamer, I like to look up at the clouds, and clouds were such a fascinating thing to watch them evolve and do things. And there's so many different kinds of clouds. And so I ended up going to grad school to study cloud physics, which was amazingly fun. If you look at a cloud, what you're looking at is a whole bunch of little tiny water drops, real little tiny drops. And in a rainstorm, in order for it to rain, to produce one raindrop, you got to have millions of those cloud droplets come together, coalesce, and then drop out of the cloud as a raindrop. And that happens millions and millions of times over in a rainstorm, for example. And none of our models can really figure that out, how it happens so fast, how you get all that water to coalesce and coagulate and fall out so fast. And that was just extremely interesting to me. Something as common as a rainstorm, we as scientists don't really know how it works. And so that drove me to go into that field. Then to answer my father's question, who's going to pay you to do that? I actually found a job in the United States Air Force and Air Force Research Lab where they were simulating clouds for like aircraft, aircraft simulators. And so I got to apply some of that arcane esoteric knowledge to doing some stuff. Then I just got into a whole string of different areas from tropospheric weather and numerical weather prediction to space physics and eventually space operations, and that led me to becoming the chief scientist. So it all started with staring at clouds, I guess you could say.
So cool. Jill, what did you want to be when you grew up?
I was always addicted to TV. I kind of fell into producing because I always wanted to make movies and make television. So that's kind of how I got into it. It was amazing that I could actually turn it into a career. But I think my parents were saying the same thing. Like, you can't just sit there and stare at TV all day. It was like, well, I was learning something because I later produced television.
My son, I was the same way when he was playing computer games all his childhood. I would say, you got to learn how to do something practical. He's a professional game developer now. It works out.
It does work out.
I have a very distinct memory of being in my grandmother's kitchen and somebody saying, "What do you want to be when you grew up?" And I said, "Well, I definitely want to be a political scientist, but I'm not very good at science, so I'm not sure how that will work out." So, I mean, but I did end up working on political campaigns. What mission are you on today?
My curiosity drove me to try to understand as much as I could about the world and how things work. But that almost led to some fear too. Fear that things would change, or things that we might, especially technology. Technology is such an amazing exponential thing. The technology we have this week is different than the technology we had yesterday or a year ago, and what we have tomorrow is going to be different. So I when I became the chief scientist of Air Force Space Command, before the Space Force was created, I started worrying about what happens if somebody develops technology that we don't, and it surprises us. They use it in a way that we didn't expect, and that's it's a healthy fear. It's not like it keeps me up at night, but it's something that you ask the question: what if, and what if things change? And that kind of drives me to this strategic foresight, trying to think through what really is meaningful for us as people, as a civilization, as a nation, as a Department of Defense or Department of War, and in understanding how, just because it's a certain way today doesn't mean it's going to be that way in the future. So let's think about how it could change, in both in a positive way and in a negative way, and how we might be surprised. And the idea is, hopefully, by thinking that way, thinking a little differently and a little bit further ahead, maybe we will avoid some surprise and maybe get ahead of that. And so that's really what I did throughout my career as a chief scientist, is try to get everybody to think. Don't just think about the problems we have today and how to solve those. You need to do that, but you also have to think about what hasn't happened yet, the unknowable future, because none of us can really predict the future. I don't know how to predict the future any better than anybody else does, but I can think about different alternatives of the future and then try to decide what I need to do to either prevent going in a bad direction or promote going in a good direction. So that's, there's a formal process for doing that. And there are futurists that I got to know, a lot of futurists around the world that do this for a living. And I sort of fell in love with that process of trying to create future scenarios and helping us make decisions today.
In all the years of doing that and working with different futurists and seeing what's possible, or things that you didn't even think were possible, what is like one or two things that really stood out to you as like, I can't believe we're able to do this?
Well, there's a bunch of them, but just one that comes to mind right away. In the 2010s, we looked at space and how space is done from the perspective of that time, the United States Air Force. And we had all of our satellites. Most of our valuable satellites are in geosynchronous Earth orbit. They're way the heck out there. They sort of hang over one spot in space. And that makes them pretty invulnerable. At least that's what we thought. They're too far away for anybody to get to and do anything to. And people at that time would bring up, well, maybe we need to have more low Earth orbit satellites in lower Earth orbit. And we would say, no, that's ridiculous. You can't, the advantage of being in geosynchronous orbit is you're so far out there that you hang over a spot on the Earth and it never changes. So you can always point to a geosynchronous satellite and it's always in the same place. Whereas a low Earth orbit satellite, a LEO satellite's going to come zooming by in the sky. It takes like 15 minutes to go from one horizon to the other. And so for that reason, we said, that's not very useful. We will never have our missions in low Earth orbit. And to make things worse, they're much more accessible. You can imagine just with a laser dazzling an optic or a sensor on a low Earth orbit satellite, because it's so close compared to a geosynchronous satellite. So there was lots of talk, and people said, no, we'll never have a lot of lower or satellites. And at the time, there were a few hundred of them in orbit. Well, now we have things like Starlink and other systems where we have not only hundreds but thousands and tens of thousands of these lower satellites. We're performing missions, we're doing communications and surveillance and all those kind of things with these very low altitude satellites, and they it's just a whole different thing that nobody really expected. As a matter of fact, we predicted that would never be the case because it seemed ridiculous, but it wasn't until people like Elon Musk figured out how to make it happen that we say, oh, that's possible. And not only is it possible, it's very useful. Comes with other problems, of course, but over a fairly short period of time, 10 years or so, that came to be kind of amazing.
And those satellites now are launching at the rate of what, like one per week?
Oh yeah, with dozens of satellites on board each rocket, so it's crazy.
The issue now is, where do you put all enough launch pads? Not how do you like build enough satellites. It's where do you put enough launch pads in order to service the satellites that need to get into space?
That's right. That's right.
I will tell you something I've probably never told you. I do brag to everyone that I know the first ever chief scientist of Space Force because I think it's so cool. I just wonder what you can share as far as like where all the bodies are buried, how many classified secrets you have. No, I'm just kidding. But like what kind of stuff landed on your desk, and what was it like day to day doing that job?
Well, it was exciting, and the space business is just intimately um, amazing and very exciting to be in all parts of it, because you have big rockets that launch things, you have satellites that are in orbit, you have the missions that you're doing. You talk about deep space, we're going to other planets and stuff. So all of that is just fascinating to me. Anyway, I think common to my generation that grew up during the Apollo era, we saw all this amazing activity in space. And with the Department of Defense, they have to worry about all of those things. They have to worry about the big rockets that you build, and as you mentioned earlier, how to keep up with the demand of all these satellites that we're launching, how to operate them, the physics of what they're doing. They're sensing. Satellites communicate and they sense and they transmit data. All those things require new advanced technologies every time, or they employ new technologies every time they become available. Just like our home computers, satellites have become way more capable due to microelectronics and the shrinking of electronics packaging. So you can do more and more all the time. So it's just a exciting area, and that comes up in all the if you think about the types of missions that the Space Force does. We communicate, we do surveillance, we take pictures up and down and try to figure out what's going on. We do missile warning and launch detection. So if somebody's launching attack, we would be the first to see it and do things. To do all those missions, that requires us to have knowledge about things like what's the sun doing, what's space weather doing to our satellites. So there's just a wide range of activities that are interesting. I'll tell you just one quick story. I sort of shifted from a natural physicist trying to study space weather and things like that to space operations in the late 2010s with a mission called Angels, which was one of the first satellites that went out to geosynchronous orbit, this very far distant orbit, and rendezvoused with another object and orbited around it, and all did that autonomously. So it was really the start of using AI in space, and we were pathfinders doing this for the first time, and that was just very exciting to think that you can control a satellite that far away that you really can't even see with a telescope other than a little dot, and you can do complex maneuvers with another object in space, and you can orbit around it, you can fly by it, you can take pictures of it, and that just led to a whole lot of new capabilities for the Space Force, and And we do that regularly today, but that was pioneering work in 2010s. That was fun to be around then.
Yeah, started with drones, right?
Yeah, right. Yeah, it's like operating a drone where it's well beyond your ability to see, and it takes a long time to communicate, can take multiple seconds to get a command up to it. You have to do it in a very careful way.
You have all these projects and there's all these areas that you want to explore. How do you decide which idea you're going to put money and resources behind?
That's an excellent question, Joe, because that, boils down to it. That was really what my job was chief scientist, was to prioritize our science and technology investments. And if you think about that, that's hard because, some scientist working in a laboratory on some new technology or capability, it might be 20 years or 30 years before that's evolved enough, is mature enough to be something useful to a warfighter or an operator or, a commercial entity. So you kind of have to have a little foresight to think where you want to put your precious science and technology dollars, given that it's going to take 10, 20, 30 years before that's realized. So you have to anticipate what is the world going to be like in 10, 20, 30 years so that you've invested in the right thing. So that's really what drove it. And we did it through this sort of discipline of strategic foresight, specifically looking at multiple hypothetical futures. You kind of figure out what the uncertainties, what don't you know about how the future is going to evolve, and figure out which ones of those are the most critical, and you build some scenarios around it, and then you can test your ideas. So if I invested in this thing today, maybe it's better GPS. How would that play out 20 years from now in these different scenarios that I've constructed? And hopefully you get a little insight in those kind of things. And that's exactly what we did. And that's why we did it.
Were there ones where you're like, "Oh, why'd we go down this road? I wish we had put it somewhere else."
Yeah. There's obviously when you do this kind of trying to project what the future is going to be, you're going to be wrong sometimes. Like I said, it's hard to predict the future, and most of the future is unpredictable and unknowable. So there are, like, again, going back to my example of the difference between geosynchronous Earth orbit satellites, way out there, and low Earth satellites that are fairly close. It's 300 kilometers versus 38,000 kilometers. We invested a lot in those far out satellites, and that's not the way the future turned out. It turns out we invest in the near ones. So you don't always get it right, but if you don't think beyond the present, and somebody else does, if you know a geopolitical adversary or a commercial adversary thinks of a new way to go before you do, that's where that surprise comes in. And so you're going to make some mistakes, but if you don't try, you're not going to innovate.
One thing that I like about your strategic foresight approach that I think you don't have to be a scientist to
Right.
derive value from, right? You don't have to be in the military, you don't have to be launching things into space, is the foundation in that is starting by asking yourself questions about where are the facts. Start with the facts and think about where they can be, like you said, in the multitude of hypotheticals, and plan for the ones that are most probable, right? Like that's business development, that's marketing, that's um in your relationships. And I think there's a lot that you do within strategic foresight that has implications in life in general. I don't know if there's anything you want to share about that.
There's uh, an analogy that I like to use. It's one of my hobbies. I have a lot of hobbies. Is beekeeping, and in that hobby, the reason I'm interested in beekeeping is because bees are just fascinating. The things they do are just, again, I'm trying to figure out what are they doing. The analogy I like, and a lot of people have seen this, the the field bees, the ones that go out and find the pollen and the nectar. They're scout bees, the ones that go find this, and they'll come back, and if they found some a source of pollen or nectar, they'll do a little waggle dance, a little figure eight dance that inside the hive that the other bees can look at, and it tells them the direction and the distance to the bushes or whatever it is that's got the source of pollen and nectar. And most of the field bees will take that direction and go find that, because they're pretty sure there's going to be some honey there or some nectar there, and they're going to go get it. But there's always a few. There's something like 10% of the field bees don't do that. They don't follow that waggle dance. They go find different directions because they know, I'm anthropomorphizing here, but they know that they could go get the quick exploit and go, if they went in that direction and that distance, they could almost be guaranteed that they'd find nectar. But that nectar is going to eventually run out, and they're going to need more places to go find it. So they go in random directions to look for the nectar. That's kind of like what strategic foresight is. We know the problems we have to solve today, and we better put people on solving those known problems. But there should be a small fraction of folks that are going off in other random directions and asking, what if something is different? What if the world changes, and what would I do then? Because that's really where innovation comes. Just look today at AI and the preponderance of large language models like ChatGPT and Claude and things like that. There are a lot of people that see value in that, and they're building tools, and commercial entities are trying to exploit the value of that AI and LLMs, and they need to do that because it's there. But then there's the other people that are thinking beyond it. Where do we go 10 years from now with these chat GPTs? And maybe we should put some guardrails up, or maybe we should promote development in different directions. What if we have artificial general intelligence? What that's a scenario. What would we do then? Or what if we consume all the power that the world has to offer running these models, and what that's a scenario that we need to deal with too. So as with bees in life, people need to go off in directions that aren't the easiest way to exploit something, but to go look for future conditions. That's what it's all about.
I think within that you have to get the right bees going in the right direction, right? Because if you have conventional thinkers trying to solve unconventional problems, you're never going to create innovation. And if you have people that are constantly wanting to diverge from the known path headed to the known nectar, you're never going to get anything done. So I just think there's a lot that you can derive from that. What do you think of Space Force as far as warfighting and how fundamental that is operationally for our national defense? It is kind of a relatively new component.
Well, you're getting down to the heart of the matter. So, as I mentioned before, the Space Force has a lot of missions right now that are well defined. They're articulated. They're things like missile warning, launch detection, communications, surveillance, all those things. Those are all really support to the soldiers, the sailors, the airmen, the Marines on the ground that are executing the joint fight, right? So if we heaven forbid go to war, the Space Force is really providing all those services, those communications and surveillance services for the folks on the ground. And that will be the case for the foreseeable future. I'm sure that the Space Force will need to do that. But things could change, and this is where you go off in a different direction and think about what could be different in the future. If we start seeing a lot of attacks of our capabilities in space, then we better have really good space domain awareness to understand if there's an adversary headed our way and wants to do harm to my satellite to prevent me to do the communications or the surveillance or whatever. And that could grow into its own battlefield. We could be doing kinetic war in space, in which case that's going to drive the Space Force to develop other capabilities, like the ability to defend against that, or to run and hide, or to carry out a kinetic war in space, which we don't want to do because of the orbital debris. But and then if you even think even further out than that, and not just for war fighting, but just think about the commercial uses of space. There are lots of visionaries out there that want to do things like manufacture products in space, whether it's pharmaceuticals or new fiber optic or whatever. There's folks that want to mine the moon and asteroids for the rare earth minerals. And, that could become a very lucrative thing in space. And just like every other domain that we've gone to, that's just going to lead to conflict, because whenever there's wealth streams, there's going to be people that want to compete or even steal those kind of things. And so that's a whole different world for the Space Force. If we're to, when the Space Force was created, one of the missions we were given was to protect American interests in space. And if those interests grow through manufacturing and mining and all those other things, we better be ready to protect those things. And so maybe that means, back to your question, Jill, we need to start investing in the ability to protect those things, the technologies that would allow us to, zip around and fight off pirates and in space and other such things. So we, in my office, when I was chief scientist, commonly called that the dual mandate. We will always have the mandate to look down from space to the Earth and support the soldiers, sailors, airmen, and Marines and what they're doing. But there's a growing mandate that we don't know how far it's going to go, but to look up and to be able to operate and do things in space. And if war fighting propagates into space, which we hope it doesn't, but if it does, we need to be ready to be there and do those things.
Working across like defense, industry, academia, and all of these international partners, how do you handle all these different cultures coming together? And how do you decide who has more say in where it's going or not?
Not very well. That's a really big challenge. Everybody has their perspective, their point of view. It's they're eating their part of the elephant, right? And you've hit on a very important thing. The the folks that are developing military capabilities need to know about the commercial capabilities that are happening, and vice versa, because if there's something you want to do commercially, you need to know that there's somebody like the Space Force there to protect you when things go awry. A lot of times, this business of strategic foresight or thinking of future scenarios is not about creativity of thinking of something new like a science fiction writer would, but maybe just bringing minds together to if you get some entrepreneurs together with some space industrialists, with some academic folks and some military folks, and talk about the big picture problem as opposed to the little piece that they worry about day to day. Sometimes it reveals a lot of insight about what the future might be like. So it's a social engineering challenge as much as anything to get those different groups of people. And you need subject matter experts from different disciplines too. You not only need the technologists, but you need the lawyers that can talk about what policies might change, the sociologists that talk about how people will change. It's a wide range of ways to look at the problem that really gets you a more complete picture of what the future could be like.
How do you think that's going to be impacted if the Sibber Sitter grants don't get reallocated?
Well, that's a big question. And the Sibber Sitters have been an area where young entrepreneurs or new entrepreneurs with an idea can get some seed money or some startup money to pursue that. And it's not by accident that the Small Business Administration runs these, because they're trying to stimulate the economy from a small business commercialization perspective.
Can you just define what Sibber Sitters are for people who don't know?
It's grants that the Small Business Administration give out to entrepreneurs who have an idea. They could be relatively small, a few $100K up to a few $1 million, but it gets can get them off to a good start in commercializing an idea, supersittering. And there is a pause right now in those things, and I worry about that because that's a motivation, or that's a mechanism that gets entrepreneurs out of the garage and into the next level up of scale and thinking through their ideas. If we turn off that spigot, we're going to have a lot less ideas to transfer later.
The Cyber Sitter program is also exclusively focused on defense. And so various components will put out their calls for the things they're trying to innovate. And there's a lag in the time and intensity at which military can move to innovate itself versus what it can contract to have innovation from that, like from the commercial side. And a lot of contracts, they're just hard to get. And so the Cyber Sitter makes it so much easier, and you can get put in line with a defense agency that then walks you through the process and helps you innovate and helps you grow your product so you have a customer. It's a really great program that I think not only do small businesses benefit greatly from, they do stimulate the economy, as Joel said, but the military, I think, defense benefits greatly from that program as well.
Hopefully it'll come back. There were some
Yeah.
reasons why it was paused, and there's some quote unquote abuse of the system. I'm not sure you necessarily call it abuse, but sometimes small businesses are motivated just to take the phase one SBIRs, which are typically, a few $100K, less than $1 million, and do a little bit. And the hope is they transition that into a phase two SBIR, which can give you a few $1 million, and then a phase three SBIR, which can be hundreds of millions of dollars to transition a capability into operations. But if the quote unquote abuse comes at the beginning, if entrepreneurs just take the few $100K, do something, and then take another phase one, and then another phase one, and a whole bunch of them in a row, you're really not progressing the technology. So I think there's some effort right now to optimize that and make sure the technology is flowing. But the other part of your question is, how do you make up for that? And I've always said this, even well before this current Cyber Sitter problem, that we, in general, underutilize. We in the Department of Defense underutilize academia, universities in innovation, and there's reasons for that too. It's hard for somebody like the Space Force to go to a university and say, "Develop me a new weapon to do this." There's a lot of barriers to that. You just think of the security barriers, or and on the university side, research professors and faculty are not necessarily motivated to go after that kind of project. They really want to get a grant to do some basic research, publish a paper on it maybe, and move on to the next thing. And that's what they're graded on as professors. That's how they move up the tenure track, is the more papers they publish, not the more weapon systems that they hand to the Space Force. So the motivations aren't really there. But I think that's much to our detriment. We need to figure out how to restructure both sides of that equation, the university side and the military side, so that we can take advantage of, we have the world's best universities with the smartest people across a whole lot of fields to think about our problems. Plus, they are the source of our future workforce. They have the students that come through it. So there's a lot of reasons to want to optimize that relationship a lot better. And I think would strengthen our innovation pipelines tremendously if we can figure that one out.
Do you find in academia that they're at the college and high school levels that they're actually training people for this kind of work in the future?
In some places, and it's hard these days. Just imagine how fast technology grows. It's hard, all of a sudden when ChatGPT-3 was released a few years ago, we needed people that were experts in large language models and how to apply it. And it takes time to develop those workforces. So it's another area where strategic foresight can be placed. But um, you know, there there's always this constant shifting of what kind of people you need coming from universities, and they need to be agile too. They need to be adaptable to, and by and large, they can be, but always can improve the system.
Data mine of the Rockies.
There you go.
I was going to say the same thing.
Jill's learned about data mine of the Rockies.
I'm slowly learning all of this cool, nerdy stuff.
The whole point of this show is to highlight people that are missionally driven. I know when you retired, you just took on, a bunch of other stuff. You didn't really get to retire. How do you stay grounded and accomplishing things when you are working on such technical stuff with so many players that you have to manage? I think that's, boils down to a lot of different things like leadership, actual self reflection. How do you stay the course on things that might start to seem impossible?
Well, that's a great question, and I don't know the full answer to that, but I think it boils down to, again, to the beginning. At least for me, what motivates me is curiosity, and then a little bit of fear thrown in there. So, those two things are pretty good motivators to keep you going and thinking about new things. And since I retired, I've been trying to think about how this new world of generative AI can be applied to this strategic foresight business. And the scientific hypothesis, so if you want to call it that, is that humans teamed with machines in the form of AI can do a little bit better job of anticipating the future, creating these scenarios, and helping us think through where we need to invest in today than either the humans or the AI could do alone. Um, so spending a little bit of time with the little nonprofit that I have called Mindset that's thinking through how do you optimize that relationship, the teaming between humans and machines for this very specific purpose of strategic foresight. And it's just fascinating, it's curiosity driven. I don't know if it's going to work out or not. Um, it's trying to figure out how to make those two parties work sort of synchronously and to amplify what each other's doing, so you get something that's greater than the sum of the parts. But there's a little bit of fear there too, because I'm afraid somebody else is going to figure out how to do that before we do. So that drives you, that gets you up in the want to do some more stuff. So.
I think it boils down to trust. When can you as a human trust the model? And when does the model need to trust the human? And if you don't have someone maybe as ethical driving that conversation, then that barrier to entry of where that trust is lowered. And I think the outcome is very scary.
Yeah, I agree 100%.
But when you have people like you working to solve it, then, it's obviously a much different conversation.
Well, and it will certainly take more than just me, but, hopefully there's a lot of positively minded folks. A friend of mine used to be the director of a institute called the Center for Positive Futures, and I just like that. We want to do our work to have futures that we want to live in, the utopian future. You remember when science fiction used to be about how great space is going to be in the future? Star Trek. Somehow it all turned dystopian somewhere, but I tend to think that with a little effort it put in today about thinking about what could be, you can drive away from the negative futures and towards the positive ones. It's better to think in advance on how to do that than to wait until it's an emergency and you got to somehow change the course of the ship in short order. It becomes an expensive, desperate fix. So it's worth spending time thinking forward.
Is there something in particular that is forward thinking that you're super excited about?
This business of in-space resource utilization, they call it ISRU, but that's just basically mining in space, mining moon or asteroids. It's always been a question about, can you go to where those valuable resources are, extract them, and bring them back to the Earth in an economic way? If you think about our current NASA missions that like went to Comet Bennu came back with just a few grams of sample, and it cost how many billions of dollars. That business case probably doesn't close. But there are people today, entrepreneurs, that are looking out um, just beyond the moon. There's a population that was previously undiscovered of asteroids that are just at the distance of the moon, which is not that far in solar system perspective. And they're actually building bags to capture those asteroids and bring them back and mine the precious minerals or rare earth materials that are in there to do something with. That technology is moving very fast. And so that's a game changer. If we suddenly find ourselves in a place where we can have all the platinum we wanted, or other rare earth minerals, that could change the economy on the earth. The nation that figures out how to do that first is probably going to have a huge and first mover advantage. It's still very speculative. Maybe it doesn't close, but I tend to think, what if it does? What are we going to do about it to make sure that the U.S. and our entrepreneurs are figuring out how to do that safely and securely and in a responsible way to have a positive future in there? If we just put our head in the sand and don't even think about it, somebody else is going to figure out how to do that. And do we want to be in that scenario? I don't think so.
The commercial side of things is really driving space, right? And space innovation in a lot of ways. Whereas in the past, it's always been the government leading the charge. I can't immediately think of historically another context where this has happened this way.
At the beginning of the space age, 1957, Sputnik's going over, and we decide we need to develop some capability in that area. We spent a lot of government money, one, because it's a hard problem, a very hard problem, and it didn't really close any business cases. So no entrepreneur is really going to make any money doing it themselves back in the early days. That was true all through Apollo and the space shuttle, but there was an enormous amount of technology that was built at the government direction. Elon Musk would not be launching Falcon 9 rockets today if not for the government investment in the propulsion systems that enabled that. So I think that's the role of the government, is to step in where there's an area where there's a really big possibility for gain or advantage, but the business case doesn't close yet, so that the entrepreneurs can't do it themselves. They just would go broke. But if the government can strategically invest in those things that put the entrepreneurs over the tipping point where it makes it worth their while to do those kind of things, then that's a win in my book.
Yeah.
And I think that's what happened in spades in space. It was a lot of government investment by places like the Space Air Force and NASA to build technology that's now we're harvesting the fruits of that, and it's taken a life of its own because it can make money for folks, and that's the ultimate piece of a capital market that makes things happen. If there's a wealth stream being generated, then people are going to pursue it. Our challenge is to find those things that where our precious tax dollars can be put to create more situations like that. Maybe it's artificial intelligence, maybe it's nuclear power, clean energy. There's all kinds of things that right now today commercial interests aren't doing because it doesn't make money for them. But if we could push them over the edge of that, that's a win in my book. That's where we should be spending our money. There's a lot of promise and possibility in quantum physics. It won't close a business case until a few key problems get solved, like how to keep a quantum computer coherent for more than a very short amount of time. Those are big challenges, big problems that the nation or the entity that cracks that first is going to be way out ahead.
Can you explain that to me a little more, just so I understand? What is the significance of the quantum physics?
Well, there's quantum just refers to the physics that happens at very, very small scale, at the
Okay.
atomic scale. But there's a few things you can do with that. It's very weird physics. It's very non-intuitive. It's things that happen that you don't expect in our daily lives. But quantum computers are a potential to revolutionize the way we do computations, and it really good at certain kinds of problems, not all problems, but certain kinds of problems that we just can't solve today. For example, just a wild example, it is thought that quantum computers might be really good at solving problems of natural origin, like weather problems. We could have models that predict weather or solve our climate problems. We predict what's going to happen with climates using quantum computers that we can't do with conventional computers. That's one. And then sensing. There's lots of interesting things that you can do with quantum sensors to see things better or detect things. For example, one potential is to be able to, from space, using a quantum sensor, detect the gravity fields that it's floating in, and do away with our GPS systems, because you can do such fine detection of gravity. And then there's quantum communications, just communicating with electrons or photons in an entangled state is just a whole new level of security and way to do communication. So, those are just three applications of quantum physics that people are working on that could make a revolutionary change in those three fields: sensing, computing, and communication. So again, it's probably right to put some government investment in that, because if the business case doesn't close by itself, it needs some help to get over the edge to make us the leaders in quantum computing in the future, for example, just like space.
Replaces ones and zeros and it scrambles it all up. So as soon as you wrap your head around that, it's totally different.
One and a zero at the same time.
Not linear.
Keeping physicists employed for a while. I just try to encourage people to think beyond the obvious, think beyond the most probable future or the most likely future. Think about what's plausible, what doesn't violate the laws of physics as far as we know it, and just spend a little CPU cycles thinking about what that future could be like, because that little bit of thought you put into it might give you the insight, might do a couple of things. It might allow you to make some investments that push us in a positive direction versus a negative one. Or it might give you the insight to see signals. If you see something that's happening in the world that might be moving us away from that single future operating environment, that's good to know. That's something that can be very helpful.
On a more personal note, I wanted to ask you a question. I know you've seen a lot and you've led a lot, but what still makes you look up at the night sky in awe?
The night sky itself. It's, as a little kid, I would look up and see the stars and the planets, and just blows my mind even today to think about how far away they are, how big the universe is, how small of a place that we occupy in that world. We're a little arrogant, I think, to think that we know everything, and that puts you in your place when you look up at the night sky and realize you're just a little pinhole in this universe. There's a lot we don't know yet, so that drives the curiosity part of me.
Thank you for being on.
Well, thanks for asking me. It's been fun.
Very interesting conversation.
Yes, very user friendly for those that are not in the know. So thank you for that.
I appreciate that. That's part of this proselytizing that I'm doing, is trying to get people from all walks of life and different disciplines, people that are experts in all sorts of things, to think about this positive future business. My advice to everybody is think long term.
Think long term, be alert, and have your bees going in as many directions as possible.
You can find this week's guest online at visionarymindset.org. And you can find us at 2bu.co. That's TWOBU.co. Do good, do it now, and do it often.